wire pull test is done to look at the properties of annealing. And what we're going to do is take copper wire, pull it on the tensile tester, and we will measure deflection and stress. So we're building a stress strain curve. Cutting the wire is very easy. I can use just a ruler set up on the table, as you can see here. And one more piece before we focus away. To get different diameters of the wire, I have a nice tungsten steel die. And I don't know if you can see the numbers or not on that, but these are the different diameters, and we're at 1 millimeter right now. So what we would do if we wanted to go to 0.9 millimeters is we would force the wire through this 0.9 die, pull it through, and it will hard work the wire, and we'll see a change in property in the stress strain curve. And so what you're going to do is pull a 1 millimeter sample just off the wire spool. That's the one we're going to do now. And then you're going to do 0.9, 0.8, 0.7, 0.6, and if you can get to it, 0.5 diameters, and test them, and you will see the curve get taller and shorter as it goes. And then we're going to take those pulled samples, because we're going to cut enough to do 2 tests, and we're going to put the samples in the oven and heat them for about 15 minutes at 300 degrees Fahrenheit. And we're going to pull those, and we're going to see that they all look like the curve we're about to build, because we re-anneal the wire. So this is an experiment in learning about annealing. We need the wire grips, and you can see these have these weighted pieces. I have set 4 inches between, or 100 millimeters. And my test sample on the computer is I want to use the wire pull, and it's the one on the bottom. And there it is, and we'll bring that up. And you'll see grip separation 100 millimeters, my test rate, and my initial wire diameter, which is not 10 millimeters, it is 1. Okay, so what I'm going to do now is set the wire up, and then we'll come back and actually run the experiment. Let me get over here, I think, to show you. This is a little tricky because you'll notice this one is upside down. But what we're going to do is put the wire in and bring it around like this. And then hold it up tight. See how I did that? And then this one comes around, still holding it as tight as I can. And then when I drop this, this is going to go a little slack. There's no hope for it. You can try kind of doing one of these numbers, but there you go. And that 4-inch wire. And the rest of this is not used. So you can, maybe I cut 30 inches. You could probably get away with maybe 25 inches. But you'll notice that you do use a lot of wire in this testing. So our test sample is right here, and the gauge length is 4 inches or 100 millimeters. Okay, let me go back to the computer. Take control. Remember, I hit my blue button, reset controller. And that should give me control of the system. Actually, excuse me, I got to come over and push the button to turn it off. Now I can assume control. See, now I have control. I'll zero my load. And again, notice now we're in newtons and millimeters, so we're in the metric system. We've put in the diameter, so it calculates the area, and it's going to divide newtons by the area. And Newton per millimeter squared is a megapascal. So this result you'll see will be in megapascals versus the deflection in millimeters. Let's go ahead and run this. So grip separation is 100 millimeters. I'll accept that. Diameter is 1 millimeter. And test input, this will be my demo wire pull. I just did that so you could put in a label. and the test begins. We're still on this first test. You can see that we are at 70 millimeters. 75 millimeters is 3 inches. The wire pulls that much. Copper is very, very, very ductile. But there it broke. And you can see the breakage here. And let me just pull that sample out. I want to show you something. That wire is stiff. There is no flopping in it at all like down here. This is absolutely stiff. It's been what's called cold worked. And it's a very brittle break on the end. Oops, get that piece of wire out of there. There we go. And that test is done. Let's return. Take a quick look. See how far we traveled? We traveled almost 3 inches. Isn't that amazing? And it's no surprise, you know, that we traveled that far because the copper is so ductile. There we go. And that'll set it all back to 0. And then you should be able to see the test results, and then we're done. And there it is. And notice again, we get this beautiful sawtooth curve indicating our break point here, and we can see that the peak load was just under 189 newtons, and that equals a stress of 240 megapascals, and the strain at break was 61.441%. So this copper wire extended itself 61% over its original 4-inch length. Rather amazing. And go ahead and do this with the rest of the wires, and you will have yourself a series of plots for cold working, and then put samples that have been pulled through the die into the oven, pull those, and you will see this original curve pop back out again. And in that way, you're seeing the effects of annealing and cold working on a metal. Here's that curve again, and what I wanted to show you was that as you pull the wire through the die and you go down to 0.9 millimeter, 0.8 millimeter, this curve is going to get a lot taller. That is, the peak stress is going to rise, but it's going to become more brittle. You won't see this 61% strain. You'll see the strain very quickly drop under 10%. So the curves will get taller and much narrower, indicating a brittle material. And then the annealed samples will all come back and look almost identical to this first sawtooth. Now remember, on the annealed samples, they're all different diameters. So when you put in the next test pull, you need to make sure that the diameter up here is set to the correct diameter. So on each test, you got to put in the 0.9, the 0.8, the 0.7. And simply enough, when you pull the samples from the oven, just use the calipers on them to determine what the diameter is. It's that simple, because they'll be all jumbled up if you're going to cook them all at once. But you do that, and you'll have all your curves for this experiment, and it'll look great. And then don't forget, you hit your Roman numeral 3 here at the end, create the Excel spreadsheet with all the graphs so that you have the data for your report.